How important is ilmenite for future lunar resources? Have you ever wondered what makes certain minerals so vital for our future on the moon? One such mineral is ilmenite, a compound that could play a significant role in lunar exploration. So, how important is ilmenite for future lunar resources? Let's break it down. Ilmenite, with the chemical formula iron titanium oxide, is a mineral that holds great promise for future lunar missions. This mineral is a rich source of oxygen and iron, both of which are essential for human life and space travel. Oxygen is not just necessary for breathing, it can also be used to create rocket fuel. This makes ilmenite a key player in sustaining long-term missions on the moon and even beyond. You can find ilmenite in large quantities within lunar mare basalts and regolith. These areas, especially those with high titanium content, can have ilmenite making up between 9 to 19% of the volume in basaltic rocks. This abundance makes these regions prime targets for mining operations aimed at extracting ilmenite. The process of extracting oxygen from ilmenite is relatively straightforward. Through chemical reduction, we can react ilmenite with hydrogen to release oxygen gas. This method requires less energy than extracting oxygen from other lunar minerals, making ilmenite one of the most practical sources available on the moon. The iron obtained from ilmenite can also be utilized for construction and manufacturing purposes on the lunar surface. However, extracting ilmenite is not as simple as it sounds. Since ilmenite is often mixed with other minerals in the lunar regolith, processing techniques are necessary to concentrate ilmenite for efficient extraction. Recent advancements in technology have led to methods that combine gravitational, magnetic, and electrostatic separation techniques. These methods can increase ilmenite concentration in lunar soil samples by up to 3 times, making the extraction process more efficient and cost-effective. Yet, there are challenges. The ilmenite on the moon does not uniformly distribute, and its physical characteristics can vary based on geological conditions. This variability can complicate the separation process, particularly for magnetic extraction methods. From a broader perspective, ilmenite is vital for in-situ resource utilization, which means using resources found on the moon instead of transporting everything from Earth. This capability is essential for creating sustainable lunar bases, supporting human life, and building the infrastructure needed for future missions. In summary, ilmenite is an important lunar resource. It provides a feasible source of oxygen and iron, both necessary for future lunar exploration and settlement. Its extraction and processing are central to making lunar missions more self-sufficient and economical. As we look to the stars, ilmenite stands out as a mineral that could help pave the way for humanity's next great adventure.